Welcome to qnawire.
Okay, so the formula for ethyl acetate is C4H8O2. And so when we build ethyl acetate, we're going to have a carbon, and that's going to wind up being attached to another carbon, double bonded to an O, single bonded to an O, with two more carbons and H's filling out the rest of the spaces. So this is ethyl acetate. You can see we have our 1, 2, 3, 4 carbons, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens, 2 oxygens. Now we're going to try to figure a few things out about this. And so if we want to know about hybridization, we're going to want to deal with the number of electron domains or electron regions there are, the number of places where we have electrons, whether they are bonded or lone pairs, doesn't matter. And so we're going to do it for each of the carbons. So let me just call this one carbon 1, carbon 2, 3, and 4. Okay, so for carbon 1, you can see that there are 4 different places where we have bonds. And so the 4 domains gives us an sp3 hybridization. So if you think about having a 1 by the s, we don't write the 1, but if you think about the 1 plus 3 is 4 domains. This carbon, there's only 3 places where there are bonds: west, east, and north. This double bond does not count as 2 domains. So there's 3 domains, which makes it sp2, 1 plus 2, 3 domains. If we take a look at 3, there are 4 distinct places, north, south, east, and west, where we have electrons, 4 domains, which makes it sp3. And the same thing for the 4th one. There are 4 places where we have electrons, so that makes it sp3. Now, what are the total number of valence electrons? Well, let's take a look at how many valence electrons there are for each of these elements. Carbon has 4 valence electrons. So we have 4 atoms times 4 valence electrons. That's 16 electrons. If we take a look at the hydrogen, that has 1 valence electron, but we have 8 atoms. So multiply that by our 1 valence electron, that's 8 valence electrons. Oxygen has 6 valence electrons, and there are 2 atoms of it. So that is 12 electrons. So altogether, if we add these up, 16 plus 8 is 24, plus 12 is 36 valence electrons. Now, of those, how many make sigma bonds? So I'm just going to go over to the left here to keep going. Sigma bonds are the single bonds. Now, I put that in quotes because they are bonds that are single, like these, but they're also the single part of a double bond. Remember that a bond holds 2 electrons. So we're going to count up the number of single bonds, and then we'll count up half of this double bond. Remember, in a bond, there's 2 electrons in a bond. So this bond has 2 electrons as part of its sigma bond. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 sigma bonds. Each has 2 electrons. So there are 26 electrons that deal with sigma bonds. Now, what about pi bonds? Pi bonds are the double part of a double bond or the double and triple part of a triple bond. So we take the sigma out. What's left is pi. There's only one double bond. We already took 2 electrons out as sigma, so there's only 2 electrons left for our pi. So we have 1 pi bond. There's 2 electrons in it. So there's 2 electrons that come from our pi bond. And how many valence electrons are non-bonding? Those are our dots. So you can see we have 2, 4, 6, 8. So we've got a total of 8 electrons. And then to just double check that we counted everything, 26 plus 2 plus 8 is 36 electrons. And if you notice from part B, that's how many we had. So we accounted for all of our electrons.